I did work for a company called Omicron for some time. It's not the Omicron that makes the virus.
I mean, in the 1940s, there weren't really as many health and safety.
Not that old, Francis.
Self-healing networks. It sounds like something from a sci-fi movie. What the hell is a self-healing network? Power lines pick themselves back up off the floor. So without further ado, Tom, please tell us a bit about yourself. I know you, but our listeners maybe don't.
Okay, so my name is Tom Prevost. I live in a small town called St. Johnsbury, Vermont, in a place that has been called the Northeast Kingdom. Not really sure because there's nothing here, but it's a beautiful place in the northeast part of Vermont. I've been born and raised here, and I've had the pleasure of working at Weidman for most of my career.
That's a good. Sorry, Tom, just to stop you there. We should mention our sponsors, Weidman Electrical Technology.
Okay.
Much appreciate them giving us the time, sponsoring us to do this. Carry on, Thomas.
Thank you, Weidman. I'm an electrical engineer. I went to school at Virginia Tech many years ago, and have been worked at Weidman for more than almost 32 years now. So I would say my strong background from an engineering standpoint is electrical insulating materials, focusing primarily on transformers. I did work for a company called Omicron for some time. That's not the Omicron that makes the virus. But they're a company that makes test equipment. So I was able to broaden my horizon and work on anything in a substation or a generating plant.
And I believe when you had a full head of hair and a mustache, you worked in Florida for a utility.
You're absolutely right. My first job out of college. Also, when I was a few pounds lighter too. So my first job out of college, I worked for Tampa Electric Company, and actually I was the guy that they would send into the generator to do the inspections, because at that time I was the smallest guy on the crew. Many years.
Yeah, I don't know.
Many years and many pounds ago.
Yeah. What does inspecting a generator mean? I have no idea what that means.
Well, there's a spot between what's called the stator winding and the outer shell of the generator that's actually filled with hydrogen, and you are able to see the laminations of the core, which can get displaced over time. So what they did is they would tie a rope around my feet, and then I would use my hands to crawl into the space with light and inspection thing. And then when I couldn't stand it anymore, I would wiggle my feet and they would pull the rope and pull me out of the generator. Yeah.
And in the 1940s, there weren't really as many health and safety regulations.
You're funny. I'm not that old, Francis.
Yeah. Okay. Very good. Well, as interesting as that is, I'm sure at some point I'll learn to understand what a laminated winding window view is, but
I doubt it.
No, that's true. Yeah, absolutely true. Well, let me explain that. So, of course, Tom's presented us his illustrious career as an electrical engineer and specialist in insulation, and unfortunately, I have to say that I come from the marketing background. I've worked in the energy industry starting out. My time in Australia, of all places, working for a local Australian technology company who were developing solutions for the distribution network, power quality analyzers through to line fault indicators, and selling them through Australia. They were, and basically I started out there and have worked in a bunch of sales, product and marketing roles. And now, as we talked about, we're both employees of Weidman Electrical Technology. And for those of you who can see us right out this window, you can see the Weidman board machine running hot in St. Johnsbury here at the end of fall. And you may also hear, for those listening, some background noise, a few honking. Is that the American term?
Honking, yeah.
Honking of the horns. Yeah, my mother always used to say pipping. You know those Italian horns in Europe, it sounds more like a pip than a honk. But anyway, you may hear some of those honking horns behind us at the vaulted trucks. So we are here, and as Tom says, it's a working site.
It's a working site, and the fork trucks have right of way, so make sure that you listen for the honking.
Exactly. Alright, well, let's get into some news to start with. So I was having a little look through the news this week, and of course, being a marketing guy, the thing that caught my eye was self-healing networks that Duke Energy were promoting, and they were referencing basically the hurricane that went through a few weeks ago in Florida and decimated parts of the coastline on the Gulf side there, and basically, we saw hundreds of thousands, if not millions of people without energy for periods of time. And, Duke were basically saying self-healing networks could certainly help in times like that, in faster restoration or no outage at all. But, right. I mean, self-healing networks, it sounds like something from a sci-fi movie or the future. And I don't always associate our engineering groups with that. So, I mean, the question is for you, what the hell is a self-healing network? Are we going to see power lines pick themselves back up off the floor and reconnect?
Yeah, I think it's a pretty generous use of the term, although I do understand it. What you have to understand is what a non-self-healing network is first, and then back into that. So traditionally, most of our distribution grid is very simply designed, and the protection of the grid is done with, in many cases, particularly in rural areas where I think this applies, you up on the power lines, you will have what's called a cutout, and this cutout is basically a fuse, and a fuse is a device that will activate if you have a fault on the line. So in the storm, typically that's when you have a tree fall across the line, or the pole falls down and the line hits the ground, and if you don't clear a fault, then the power is just going to go where it wants to. That's just the way electricity is, and I'm sure we'll talk about this a lot in our conversations, but power,
in my education,
in your education,
Thank
but
you.
Power ultimately wants to find ground. And if it doesn't have an unimpeded path to ground, then all the power that you want to have available on the system to use, to heat your house or for your microwave charge your car, is just going to go directly into the ground. So what you want is ability to clear that fault or stop that path to ground. And traditionally that's done, again, with a fuse, and it's called a cutout. So when the fuse activates, it actually flips open and falls down so that you can visually see it. And for example, when I worked at Tampa Electric, if there was a storm, then we had storm duty, and folks would have a designated area, and you drive around and you see where the cutout is open, and then you know that that's the area that had a fault. And then you would send a crew in there to clear the tree off the line or fix the power line or everything like that. Still today, that is pretty much still the technology. So the key for that is, number one, it has to be visually seen. And the other thing is that there's no technology that can go back to a central command center and say, this is where the fault is, that's where the fault is, that's where the fault